Welcome to the channel Knowledge Star Continuous Knowledge Excellence. My name is Karuna Singh. Today I welcome a very special guest who is Assistant Professor in the Department of Propulsion Technology, Széchenyi István University. Please welcome Dr. Tóth Álmos Dávid. Welcome, Dr. Tóth.
Yeah, hello. I'm glad to be here and thank you for the invitation.
Thank you, and even same over here. Well, how are you?
I'm fine, thank you. I'm glad to be here. It's quite winter outside, but the sun is shining, so my mood is starting to get better and better.
Okay. Can you tell us a little bit about your background and how you became interested in mechanical engineering?
Yes, of course. During my secondary middle school, I felt that I was good in mathematics, physics, and this kind of subject. And after that, I decided to join to the mechanical engineering course in the University of Miskolc. So after my bachelor studies, I decided to come to Győr, to the Széchenyi István University as a master student, as a vehicle engineer on the specialization of internal combustion engines. The research topic of the department is mainly the typology of the internal combustion engines, and I've started to work as a trainee, as an intern at the department. And after my graduation, I started to work at this department, firstly as just a department engineer, and then I joined to the education activities of the department as well, joined the doctoral school, and in 2022, I just finished my PhD studies, which is about nanoceramic particles used as lubricant additives.
Well, what do you think are some of the most important skills or qualities for a successful mechanical engineer?
Yeah, it's quite an interesting question. Everybody thinks that engineering works with machines, with different kind of equipments, and not mainly with humans. That's why engineers usually or sometimes lack the knowledge how to deal with different peoples, how to work in groups. And I think that's one of the most important mistake from the people's brain, because as an engineer, you have to be able to work inside a group, which means you have to learn how to work together with different people, different engineers. And this is one of the main things a mechanical engineer should learn as fast as possible. Otherwise, the engineering skills will be lower. And according to my experience, the companies all around the world are searching for engineers who can integrate it into their employing groups and courses. And that's the reason even mechanical engineers have to work together with other people. So the soft skills like presentation skills, communication skills, and so on is equally important as the hard skills like knowledge about ceilings, bearings, and so on. But it's also possible that soft skills are even important than hard skills.
Well, in your opinion, what are some of the biggest challenges facing the field of mechanical engineering today?
Yeah, biggest challenges. I think as an engineer, we always have to search for new ideas, new possibilities. We have to design new machines. And one of our biggest challenge seems to be that we should use the available energy sources as efficient as possible. Not just the electrical energy, but our energy from for propulsion technologies and so on. And this is our biggest challenge to find the sources which can lead us to the future, which will be more energy demanding than today.
Fine, then how do you think mechanical engineering will change or evolve in the next decade or two?
Yes, so I think the whole engineering will be different. I don't know how this kind of scaling will be, so how different this kind of engineering will be, but it seems to be that the IT will be more and more important than the mechanical engineering. For example, in case of a vehicle, it's even important how you do the controlling of the engine, the controlling all of the devices of the cars than previously. And one other thing is that today there is lots of hints and guidelines which you can find on the internet and any other sources how to design, for example, an engine or a part of an engine. And as an engineer, we have to decide from this kind of huge field of knowledge, which is the good knowledge, which is the bad knowledge, which is valuable for us and which not. And I think this will more and more important in the future to find the literatures, the sources, the programs, and so on to make the engineering life easier. And this also includes the simulation tools. But we cannot forget that simulation always goes hand in hand with the validation process. So we have to make sure the simulation result shows the reality, and we only can do that if we validate our simulations.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now. Okay, can you discuss a project or a research topic that you are particularly proud of or excited about?
Yes, of course. I would choose my PhD topic because that was one of the most important topic for me. My PhD research was, as I have mentioned in my introduction, about nanoceramic particles, which we mixed into different lubricants and tested, and we have tested their tribological results, how it affects the friction and wear properties of different specimens which we have tested, with the main goal that we find some particles which can provide friction reduction and anti-wear properties for the lubricants even better than the conventional additives. After proper literature research, we have created self-developed measurement method, how we can test and analyze this kind of lubricant samples, because, as you know, if we would put this oil sample into an engine, it would be very expensive to make fired engine test measurements. So we have decided to use ball-on-disk driver system, and we have developed a new measurement method how we can test the tribological effects of these lubricant samples effectively. After that, of course, we had to make sure that the nanoparticles can stay in homogeneous status inside the lubricant, because heterogeneous oil sample cannot be tested correctly. We also have developed a mixing procedure which fits our requirements. After that, we have tested 3 different types of nanoparticles. These are all ceramic particles, namely zirconia, cupric oxide, and yttrium nanoparticles. We have tested their tribological effects with the nanoparticle concentration between 0.1 and 0.5 or 6%. And we have defined different effects, which is important to understand how these particles are working. My literature research showed that lots of researchers testing these kind of nanoparticles, but they cannot explain how these particles are working, because maybe they lack some testing equipment or interested to go further. I don't know, but it was a very high lacking system of these literatures. So I have decided to mainly concentrate on explaining how these particles are working. And we have defined different effects in these kind of particles. For example, in case of the zirconia, we have defined that these particles can fill up the surface roughness values, resulting in a smoother contacting surface. So it acted like a polished surface. And also the triple-sintering effect was established, which means that the particles were pushed into the metal matrix, and they have provided wear protecting film on the surfaces. In case of the cupric oxide, it was much more interesting effect, because in case of hydrocarbons, the cupric oxide could react with the hydrocarbons. It was a cupric reduction effect, and elemental copper was formulated during the temperature and the circumstances of our testing. And this kind of elemental copper was adhered to the surface. And this adhesion meant that this kind of copper has acted as a friction reduction and wear reduction layer on the surface. In case of the yttrium nanoparticles, this was the last particle in my PhD thesis. This yttrium worked similarly than the zirconia, just its effect was significantly better. For example, in our testing, yttrium produced more than 90% of wear reduction effect compared to the reference oil sample. It's important to mention that we have used base oil without any extra additives to make sure that we only test and measure the effects of the nanoparticles. So that was the reason why we could define this kind of very high amount of anti-wear reduction effect percentage of these particles. And we have decided that these particles can be the future of the additives, but they have to be further tested. For example, as I have mentioned, we have to check the correlation possibility, the cooperation possibility between conventional additives and these kind of nanoparticles, because it can happen that some effects would be canceling each other. So it's also not a good option. And as you know, in case of internal combustion engines, the exhaust gas emission becomes more and more important. And currently, we don't know how these kind of nanoscaling particles would affect the exhaust gas emission.
Really amazing. It's really amazing.
And that's I would say, the middle scaling explanation of my PhD research, and it was the last of my 4 to 5 years. And I'm very glad that we have currently a new PhD student who works with my research topic further, and we are trying to find this previously mentioned cooperation effect between conventional additives and nanoceramic additives to understand how they're working. And we are planning to prepare a lubricant sample which is capable of being used in a real internal combustion engines, and it contains some kind of nanoparticles. It is our main goal for this research.
What advice do you have for students who are interested in pursuing a career in mechanical engineering?
I can suggest to students that they should start going on their path. They should decide as soon as possible, mainly in the secondary grammar school, that they would like to work with this field, and they have to start getting better and better with mathematics, physics, and these kind of subjects. And after that, they should join to the university program. If it's possible, then in an English language, because our world is mainly English languages. So they have to join to a program. And if they have time, they have to join some extra activities as well. For example, join to an internship of a company, or join to a formal student team, which we have in the university. And I know that in several countries there are more hundreds of formal student teams, and it is a very good opportunity for the students to learn the previously mentioned soft skills, not just the hard skills, but the soft skills. So it's very important to do some extra activities next to the normal education. But I would like to highlight that the students should not go to the other side of the wall and concentrating on the internship or on the formal student and neglecting the university. So both is equally important to be a good mechanical engineer.
Absolutely.
From my point of view.
Absolutely. So it is really, really very important that a person should have soft skills. It is really, it is really important. So thank you, Dr. David, for this wonderful interaction. And thank you so much for your time. So yes, thank you very much. Okay, over here, I want to tell you one of our products, that is APID, which stands for Academic Profile Identity. It is an innovative academic network for the researchers, academicians, students, scholars. So if you want to explore APID, you just have to visit apid.journalslibrary.com. Further, I would like to tell you that kindly subscribe to the channel North Star and share this as much as you can. So yes, thank you very much. Thanks a lot.
Thank you very much for this opportunity, and I hope my career path can be important for the future students and future engineers
Yes,
of the world.
absolutely. Okay.
Thank you very much.
Thank you so much.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.